there. I thought we would take a look at a non-homogeneous solution with initial values so that we actually have to look at finding the coefficients. So something to remember is that the general solution for a non-homogeneous second order differential is when we find the solution to the homogeneous corresponding equation, and then we add to it a particular solution. And I'm going to play this out for us so you can see what I mean. Let's start with writing the homogeneous equivalent. So basically, if we had a 0 on this side, it would be homogeneous. So let's write that to start with. So it'd be y double prime plus 3y prime plus 2y equals 0. And we did this in previous weeks. We did this in previous videos, but I'm going to play through, and we let y equal e to the rx. So y prime becomes r e to the rx, and y double prime becomes r squared e to the rx. Okay. Then we make our substitutions. So y double prime becomes r squared e to the rx plus 3 times y prime, that's r e to the rx, plus 2 times y, that's just e to the rx, 2 times e to the rx. And then we can factor out an e to the rx. Gives me r squared plus 3r plus 2. And then we can factor that, let's see, r plus 2, r plus 1. So we get solutions that r is -2 and -1. Okay, so we get to the solution to our homogeneous corresponding equation. We get y equals some constant, some coefficient, e to the -2x plus another coefficient, e to the -x, -1x, which is just -x. Okay, now that takes care of the first part. The second part, the particular equation, is where it gets a little bit gray for area for some students. Okay, what it means is we have to look at the other side of the equation and ask ourselves, okay, what could y look like? Well, y, if it's going to have its second derivative plus 3 times its first derivative plus 2 times the y itself, it's going to have to look something like this. So we actually kind of peek over to the other side and take a little bit of what we're seeing there. So I see a power of x, okay? So I know that my particular solution, and some textbooks call this y of p, is going to have some power of x, but it could have a coefficient in front of it. So I have to consider that. I'm going to let a be a coefficient. It could have a constant. So I'll let b be the constant. And then it's going to have an e to the x term. Now you'll notice I put a coefficient in front of e to the x because I don't know. And I put a coefficient in front of the x because I don't know what that could turn out to be. So I hope you're seeing how I get the idea of peeking over at the other side to get a taste of what that might look like. Now that I have picked this out, and I didn't calculate this, right? I have to look over here to get this. But once I do, then I find my derivative, which would be a plus c times d e to the dx. And then take my second derivative. Second derivative would be c times d to the second e to the dx. Okay, now we're going to go back to our equation here and make these substitutions. So we have y double prime. So y double prime would be c times d squared e to the dx plus 3 times y prime. Now I'll have to use a parentheses for this one. So it's a plus c times d e to the dx plus 2 times y. And I'm just going to write this on the next line here. 2 times ax plus b plus c e to the dx. And that has got to equal x plus 18 e to the x. Okay, I know that does not look pretty. Let's clean it up just a little bit to make it a little bit more usable. So I've got c times d squared e to the dx. I'm going to distribute the 3. That gives me 3a plus 3c d e to the dx plus 2ax plus 2b plus 2c e to the dx. Okay, and that still equals x plus 18 e to the x. We're still okay. Now I want to kind of group them together. I'm going to group the terms that have the e to the dx with it. So that's these 3 here. Let me underline them so they're a little clearer. Here, here, and here. Okay. So I'm going to take them and I have c d squared plus 3cd plus 2c e to the dx. So you see what I did there, right? I took all the coefficients and think about it. If I distributed them back, you would get these terms. Okay. Then I have just the one 2ax term that has an x with it. And then I have 2 terms that have no x, no variable with them. And so that's 3a plus 2b. And that has to equal x plus 18 e to the x. Okay, now look at what happens. Okay, the only term that has an x by itself with it is the 2ax. That has to equal x. So I've got 2ax has to equal x. So 2a has to equal 1. So a's got to be a half. Think of this a lot like you do partial fractions when you're getting ready to integrate, where you have to find a, b, c, and d. It's kind of the same approach. Okay. Next, let's look at this term that doesn't have an x with it. I hope you can see there's no term here that doesn't have an x with it. So I know this guy has to equal 0. So 3a plus 2b has to equal 0. We know that a is a half. So we've got 3 times a half plus 2b equals 0. So we'll move the 3 halves over, making that negative 3 halves. And so b is actually negative 3/4. Okay, now notice then our last and final term is this term. But notice the d here is going to have to equal 1. There's nothing else that's going to give us the e to the x term. So we got that d equals 1. That part's okay, but I know this long guy is going to have to equal 18, that coefficient there. So I've got c times d squared. Don't worry, d is 1. We'll take care of that in a minute. cd plus 2c equals 18. And if d is 1, then I've got c plus 3c plus 2c equals 18. That gives me 6c equals 18. So c is 3. So here's what that means. I just found that my particular solution is actually 1/2 x. Oops, and you can't see that. Let me scoot over a little bit. Is actually 1/2 x plus b, which is negative 3/4, plus c is 3 e to the 1x. Okay, so far so good. We found our general solution to the homogeneous. We found our particular solution. And now we're ready to put them together, because remember, the solution to this is going to be the sum of the 2 of those. So let's add them. Okay, our combined solution is what I'm calling it. The combined solution would be the c1 e to the negative 2x plus c2 e to the negative x, and then plus our particular solution. That was our 1/2 x minus 3/4 plus 3 e to the x. Now, because we were given normally I could stop there, except we were given an initial value. So remember, we were also told that y of 0 equals 0, and that y prime of 0 equals 1. So we got to use these to find out what these coefficients are. Let's go ahead and plug in 0. So I've got 0 equals c to the 1, e to the 0, it's going to give us 1, plus c sub 2, e to the 0, again, going to give us 1, plus 0, minus 3/4, plus 3, because e to the 0, again, going to give us 1. Add these two together, we get 9/4. So we'll move it to the other side. I've got that C1 plus C2 equals negative 9/4. And I got to stop there because I can't go any further. Now we're going to use this piece. We've got to take the derivative of this. Okay. So my derivative becomes, okay, negative 2 C1 e to the negative 2x plus negative C2 e to the negative x plus a half, 0, plus 3e to the x. Okay, so now we can plug in 0, set it equal to 1. Let's see, I get negative 2c1 minus, nope, plus, nope, minus c2, sorry about that, plus a half, plus 3. Okay, so 3 plus a half gives me 7/2. We'll move it over here. That's going to give me negative 5/2. And that equals negative 2c1 minus c2. Now, probably I would stack these, and I'm going to look to do a little bit of elimination. I'm going to add them together. So when I add them together, notice the C2s cancel. I'm left with negative C1, and I've got to add negative 9/4 plus a negative 10/4. That gives me negative 19/4, and that means that C1 is positive 19/4. Now, we can find C2, either of these two equations. I'm probably going to use this one. It looks a little easier. Negative 9/4 equals C1 plus C2. Let's put in the positive 19/4 for C1. We'll subtract it to the other side. That's going to give me negative 28/4, which is negative 7. Okay, so now that we have our initial values, we've used them, we just plug them in here. So I get y equals 19/4 e to the negative 2x minus 7 e to the negative x plus a half x minus 3/4 plus 3e to the x. Now that is a lot, but that is our solution that we found. So I hope that helps you with our non-homogeneous solutions that we're going to be looking at in this particular module. So please leave me a comment or question below. I'd love the opportunity to help. Bye for now.